Oh gosh, I've been talking for 5.5 minutes muted. Thanks for pointing that out, Abhishek. Also, that's a very nice cyanide and happiness image you got there. Yeah, so let's start that over again. I can always trim that out when I go to make the highlight or just I can edit the DVR that's left over after this, the recording. And we'll trim all of that out. So, let's start again. So, and now this is going to be horrible because I've already said some stuff. I'm not going to remember what I said or didn't say. But what we're getting started with this evening is this bottom box down here. This is going to be our tester library that's going to serve as a framework for doing custom test sequence execution and management of test systems. So whether you're doing some kind of medical device where you've got to measure electrical parameters, mechanical parameters, maybe you're doing some vision inspecting, things like that are all going to be, all of that is going to be easier using a framework like this. Obviously there's Test Stand, which is very big, very powerful, can do a lot more than just LabVIEW implementation. This library that I'm working on is going to be 100% LabVIEW. But it won't do things like give you, well, it's not going to give you any results output. That'll be up to the application developers on how they want to accomplish that. But it's not going to give you HTML. It's not going to give HTML report generation. It's not going to automatically push anything into a database. That can all be done up at, maybe you've got some reuse database libraries that you write to transform results into database entries, or just generating PDFs or whatever format you need for your tester. And then the application will also create this child class of the tester class, which is going to encompass all the hardware devices. So maybe it has some camera and vision processing, analog and digital I/O for interfacing with parts of the device under test, anything like that. In this base tester class, that's going to be the main part of this library. It's going to be the largest part of this library, and that's going to handle running through the steps that are provided as part of a sequence. So the sequence, relatively self-explanatory. It's initially just going to be an array of steps, but then it's also going to have 4 special steps that are defined. They're going to be handlers for different ending conditions. So if a step at any point returns an error out of the step, the tester is going to stop running the rest of the sequence, and it will instead invoke the error handler, and that'll give you a chance to make sure all of the hardware gets reset and put back in a known good state. Similar for abort, the tester will call an abort VI on the step that is currently running, so it doesn't have to wait for the step to finish running. And that way you can write some potentially long-running steps. It's like you're moving something, or you're taking a series of images and then analyzing them, and that stuff can take time. So if there's a safety concern at some point and somebody hits an e-stop button, you want to be able to have some abort handler code run right away. So the execution system will abort the VI running for the current step, and then invoke the abort handler similar to an error handler. There will also be a failure handler. So at the end of the sequence, if a test fails, you can do that, and you might do things like turn on a red stack light if you've got a series of systems out on a floor somewhere, part of a manufacturing facility. Maybe you've got like one person that's managing 5 different machines, so they can just glance over and say, oh, that one failed, I need to go. I'll let these other 2 finish first so I can get them done, and then I'll go over there and I'll check out that system and see why it might have failed. And then there'll be a success handler, which part of your success handler might be generating the results file, whatever log format you're using. Maybe it pushes it into a database. So the base tester class is basically just going to be the sequence execution system. It's also going to keep track of the current results that are being collected. And then as it runs steps, it'll pass the current results instance into the step so they can add intermediate results into it. And then it'll track some automatic results entries, such as whenever a step completes, it can put an entry in for that step. And then eventually, once we get enough of this done that it's time to start testing, we'll start on a some kind of child tester class that will do some dummy instruments just so we can run some simulated testing, probably do some random number generation so we have, maybe like a 30% chance of failure or something, just so we can run through and test all those aspects of the code. And then our top level application, which would be comprised of our user interface, potentially any logging behavior we need to do, database connectivity stuff. My dog must see another dog outside. Okay, so let's get started. We are just starting with, I've got the tester library set up. I've got 4 empty classes. They've just got my common folder layout that I like to start with set up in them. And we do have a GitHub started for this. So let's also get it set up as a Git repo on disk. Do a git pull to get the starting git ignore readme license files that GitHub has started it with, and now we're ready to begin. Okay, loud noises. So what do I want to start with? Let's start with results. We're going to start with a couple of type definitions just so we know what we're collecting. And this is going to be a result entry. It's going to start with the name for the result. The other thing we're going to need. I do want some of this stuff. You know what? No, never mind. I take that back. Because I'm organizing this on disk a little bit differently because of the bug that is in the 2020 Community Edition beta, which means you can't put classes directly in libraries when you're first creating them, so I don't have stuff nested in folders the way I normally would. But the other type def we need is an enumeration of a result type. So there's no result. We can use this if something hasn't been set yet. Maybe something's in progress. Pass, fail, error, and abort. These are going to be the main result situations that we keep track of. And then I couldn't decide what data type I wanted to use for the value when I was working on this last night. However, I think I have decided that I do want that as a variant. But we will provide, in most cases, specific VIs for putting in numerics, strings, booleans, things like that. So this is going to be an entry. Now, Do we want results to be by reference? I think we do, because one of the things we're going to want to do is, while results are being collected, we're going to want to update our user interface with whatever the most recent item was that was collected. We don't necessarily want to wait for a step to end, because one of the things that this framework allows you to do is it allows you to have some pretty long running steps. And a step isn't going to equate to one pass-fail condition. An individual step might have 10 conditions that it has its own logic for. So with something like test stand, you could put some high and low limits, or like a low limit or just a high limit, or something has to be equal to some value. And then test stand has conditions built in. Whereas with this framework, your steps will be directly specifying whether something passed or failed. So that means we're going to need a reference data type, or a reference type definition. And I'm actually going to do 2 references, because we will want, well, at some point we're going to want some mechanism for some kind of event or callback mechanism, so the UI can receive any new updates that are made, or any new results that are added. Although I'm thinking, if we, instead of getting the results instance and then steps can push new results into that, steps will already have access to a tester instance and can instead push new results into tester. I don't know which one I like better, but anyway, so we might do 2 different refs in results, one for the actual list of results and keeping track of what the overall result is. So for instance, the first time we find an error, the overall result for that test is going to become an error. If we get an abort, it becomes an abort. The first fail we see, it becomes a fail. And then until we get to the end and say, okay, we're done with these results, it will then look, and if by that point it hasn't gotten a fail, abort, or an error, it will then mark it as passed. So the result is just going to be an array of entries. It's going to be our overall result. And each result is going to need a constructor. Ooh, I need to edit my icons. And if at any point somebody has any LabVIEW questions, they don't even necessarily need to be related to what we are working on at the moment. I'm here for kind of doing a little bit of LabVIEW tutoring, but in doing that, I learn a lot. Let's see, this is the result. So at any point, feel free to stop and ask. This initial part of me just kind of setting up the skeleton of what these classes will look like is going to be relatively boring, and there's not going to be anything mind-blowing in it. I'm going to change you to a constant. Create our data value reference that we can put on the class. And the reason we're doing this as a reference is so that we can share this data across different processes. our execution engine, in order to have the abort capability, we need to be able to call the abort VI invoke node on a single VI that isn't part of another VI's execution chain or another VI's call stack. Anytime you abort in a VI, any VI that directly called that VI will also abort. So we're going to be running these. We're going to be running the actual steps via invoke nodes as their own top level VIs, and so they're going to be running asynchronously, kind of in the background to an extent. So we're going to need to be able to. We're going to want to get that data in and out of those steps without necessarily waiting for those steps to finish. And the way I always accomplish that in my code, most of the time, is with DVRs. I don't use actor framework or anything like that. So 9, this was our constructor method. I always put the new glyph for my constructor so I know what I'm looking at right away. So if anybody that's watching, what kind of projects do you work on in LabVIEW? Insert. I should have done this the quick drop way. Would have been quite a bit faster, but that's all right. Okay. I'm gonna need a cleanup where we get rid of our DVR. So it's funny. I've in this generally a good habit of cleaning up any reference types, closing references, deleting data value references. However, one of the shutdown performance issues that I was having with my panel library that I presented on the 22nd, so what was that? Just under a week ago. The answer to fixing that performance issue was to not close a reference. Turns out when you call the close reference, in order to maintain thread safety, they've got that VI that node call will actually run in this like special root loop, which blocks a whole bunch of other stuff from running at that time. And additionally, it has to wait for the root loop to become available to do a close reference. But it turns out if you just leave that reference open, LabVIEW will clean that up itself when the VI hierarchy that created it closes, and it does that without hanging up other parts of the programs. So I felt very dirty and had to leave a reference open, but that turned out Actor Framework did that. That's actually how I figured out how to overcome that. Is there is a case where Actor Framework leaves their core, I believe it's their core VI, gets left open and just left for automatic cleanup. So I'm just going to put some placeholders for some VIs that we'll fill out later. So we'll set up some VIs for managing the results list. Actually, you know what? I think I'm going to get rid of that clear. Because we don't want any of the steps. Well, no, you know what? We'll leave that in there. Because if you write how would you accidentally run a step that accidentally clears out results? Oop. Hey, I hit the end key. There we go. Thank you. Okay, no, that doesn't do what I thought it would. Replace system string. So I was trying to figure out how I wanted to design this framework and have this framework extended by, you know, the application layer. I was just a little bit too tired last night. Probably a little too much coffee during the day to be able to figure out exactly what I was trying to accomplish. And this one we're going to do a little bit differently. So this is going to be string. This is going to be how we do Boolean results. Is we're going to have, so external to this VI, we don't have to have a select or a case structure. We can just have a nice little shortcut that'll default to fail and pass for the different Boolean values. So that means we're going to set these guys as the default value. So if true is pass and false is fail, you don't actually have to wire these in at all. You can just rely on their default behavior. And then, of course, we'll have the final type. I keep thinking name in my head, because that's what I'm going to be naming this string. And so when I go to do the quick drop, I start typing an N, and that ain't what I want. And again, the idea is that the application or the test code you write is going to know what kind of results you're generating, and should be able to handle this. There are type inspection VIs you can use to see if it's got a number or a string. Let's see, properties. We're going to want some properties. So we got overall result. Entries. Just use one of my snippets to grab this out. This is going to look very similar, except it'll just be for the entries. Oh, that fits perfectly. I love when there's just one pixel on either side of a word. I think for now that's going to be it. I think we will make one VI. Do we want an entry string? So we're going to have a VI that takes in the regular entry, and we'll spit out the string entry. We are going to want error handling on this. Because it could potentially have an unknown type in that we don't know how to convert to a string by ourselves. But for most use cases, you'll just have numbers, strings, booleans, things like that in there. So we'll have some nice convenient functions you can use to just get all of them already as these string values. You can just very quickly create a table or some type of user interface for spitting them out to data log files. Let's see. So line 1 text. This is going to be... Nope, we're not going to use that. We're going to use... to... What? Let's do the result first, then the name, and then the value. And then I can stick the format into string up here. Okay, now from this we get an enumeration that gives us a type, and if it's a type we know how to handle. So I'm going to create a constant so I can look at these. So we're going to get rid of this case default. So anything that we don't know how to handle, we're going to generate an error. Variable has invalid data type. I don't know if I like data type mismatch. That one's not bad. There we go. LabVIEW does not support the data type of this property. We'll use that one. Okay, so types we support. I8. I8. Right, data. Well, no, we're not actually going to support. Well, there is the variant where they can pass in arbitrary data types. But since we don't have our own entry for that, do we want to worry about that? I think we don't. I think I'll make my life easier on myself. Anything you're passing in directly as a variant won't be supported. So we've got that. We have got a double float. Actually, what we can do, we'll duplicate this case, change your representation to a double, and then that one. We've got string. And we've got a Boolean. And then I think for that we just use a format into string. And I think that's it for now. Anything else we won't inherently support, but that will make some initial testing and development much faster and easier. Oh boy. We're gonna start this already. And we'll do another definition folder. Conditional terminal. If at any point we get an error, we stop running. And to prevent people from not checking the error case and just putting whatever happens to work through, we'll put a nice select structure up here so we return an empty results if there's any shenanigans happening with the data types that are passed in. not want to select the select node. Oh yeah. And we want to do that as well. I think we'll move this to the bottom, like that. And then, as I said, if you're putting your own data types into the results variant, you'll have to get the regular entries array and do your own type inspection on it. Okay, that is, for now, until we figure out how we want to push these updates to the user interface, this should be it for the results for a while. Let's go ahead and set up the sequence. Oh, nope, just the class, please. And just so that looks better, let's get our step icon set. So these will be the special steps that you specify anytime one of these conditions is met. And boom, here's what a sequence looks like. Oh. Yeah, right, because there's a... It's not a file, but let's name that. What do I want to call this? Steps? definition. We'll call it steps for now. Name isn't super important. Now, a sequence is not going to be by reference. This is going to be purely by value, because it is mainly just a container for steps. The sequence itself is not going to store any state other than what steps might contain. So let's see. We're going to want a VI. We're going to want to pass in a result type. And then we're going to get out the handler. That corresponds to that result state. It's muted. So there's going to be one case where we can generate an error. But otherwise, we're going to return something for every other case. As asked, you mostly do projects related to consumer product testing, usually end-of-the-line testing or PCB functional testing. Ah, so you are interested in a framework like this. Do you guys use test stand already? That works. I dig it. And by what previous part do you mean? YouTube stream status keeps saying my audio stream's current bitrate is lower than the recommended bitrate, and it's saying my bitrate is 0. I'm assuming my audio isn't cutting out. And it's saying my bitrate is 0. Yeah. So I don't know what this is complaining about. Does OBS have something where I can lock it to 128. I mean, it's also at 160, so that's 160. Last time I checked was greater than 128. Oh, right. We need to put that there. Do we... Yeah, you use test stand in some projects. The deployment cost is higher. Yeah. Also, once upon a time, when I was still part of third-party contracting, I was used to be part of an alliance partner for National Instruments and LabVIEW. Tried doing a custom user interface for test stand. We'll not do that again. Actually, we don't need this type definition at all. Explore. Delete. Sure, we'll save you. Get rid of you on disk so you're not... We don't have extra stuff in there. And we'll do it this way. Hide full names. Pass. And since that default case isn't going to have a handler that gets returned, we will pass out the default type. That could potentially cause some issues later on, but oh well. They should know that they won't get something useful out if they pass in no result. Okay, easy peasy. That's right, not a reference type. Don't need my reference snippets. And then this way, this will be the VI, the property our tester base class uses to get the array of steps that'll then iterate over, running them in sequence. And seeing what they return or what any results that they generate are. Let's see, so it's going to get steps. Yeah, so Abhishek, I'm hoping I'm pronouncing that correctly. I mean, this is going to take a couple of days to implement fully, but it should give you a pretty good idea if it's something you're interested in or not by the time I finish streaming this evening. I will not... In our case, each test case have their own configuration, which they can be more than just limits. in these test cases, tens or 100. So that can be something that is specified by the application layer. So this base step type just has some abstract VIs, abstract meaning that they're dynamic dispatch and must be overridden. And then up here at your test test system layer, so it might not necessarily look like this. These could be like separated out here, and then you've got another set of libraries that are your user interfaces, things like that. Maybe you're going to run headless testing, and your overall architecture would look a little bit different. But these steps are implemented by whoever is implementing all of the test machine hardware, controller stuff, and all of your testing logic. So if you need your steps to handle some configuration, you could put that into your child tester class, which knows about all the devices, hardware, the type of testing that tester is built to do. So the idea is that this class will map one-to-one for the type of machine you have that performs testing. And I mean, it could be an entire test stand that has multimeters, PXI chassis stuff. Maybe you got some vision inspection stuff. But this is going to map one-to-one. And there may be some intermediate layers for you've got like 4 or 5 different stands that are all mostly similar. But your tester could handle that configuration. And part of the way this relationship works down here is every time a step gets run, the current tester instance gets passed into the step. And then because it's going to be a child step type, it's going to know that it's written to run on some specific tester, so it'll be able to typecast that and then pull whatever stuff it needs out of it. And that will be something that we might not get to this evening, but but if you wanted to, so as far as how the libraries are organized, that's up to you. You could have a library that's written that is like, so you might have, let's say you have 5 different test stands that test a product at various stages of assembly. You might have one overall library that has all of the configuration for the entire item, start to finish, and then just each machine has steps that only look at certain parts of that, and then so now you don't have to have 5 different libraries. Outside of this tester library, it's up to you. The whole point of this tester library is just to give some features out of the box, like results collection, stepping through steps, responding to failures, responding to errors, having the ability to abort an in-progress step. Maybe so electronics testing might not have something like this, but if you've got some kind of mechanical system that has motors that move things, and somebody reaches their hand in the machine and trips a light curtain, you'd want to abort the step that's running and make sure all the motors have power cut to them, so it can't continue introducing additional forces and maybe somebody pinches or loses a finger or something. So it'll have stuff like that, and then whatever inherits from tester and whatever overridden steps get or whatever child steps get created can do whatever they want. So this is very lightweight. This is not a test stand. This is not going to have if you want to loop a set of steps 100 times, you could create different actions as individual steps, and then instead of wiring each of those in, you could write another step that just has its own for loop structure on its block diagram, and it knows that it can call those 3 other step types in sequence, and then you just wire 100 into the iteration count terminal. And depending on how nicely people name their classes, they may want to override this VI. So this VI will take the class name and strip off any qualifiers. So libraries, anything like that. What am I doing? I'm looking for the class name. I think I just want to do this as a single regular expression. I think $sign anchors to the end. I always get $sign and caret confused. Boom. So default behavior is whatever the run type name of a class is minus any library things it's contained in. It'll use that, but if you've got shortened names or you've got some specific naming scheme you use that wouldn't necessarily be as readable for things that are being put into results for an overall step result, you could override this and provide a specific name. Yeah, so again, test configuration can be more than just limits. This framework itself has no idea what constitutes potential pass-fail conditions. It's not like test stand where you've got this number must be greater than this, or this number must be less than this, or this string must be equal to this. There are these add entries where you name the result. It's typically be like test idle voltage, test display initialization current consumption, whatever you need to name the different lists of items that you're testing for. And then we've got a couple different types, or you can just pass in any type, but then you lose out on some of the utility abilities that this will give you for generating like string tables, things like that. But you pass in what the result is. In the case of the Boolean, we've got some stuff that'll default to fail for false and pass for true. But it's up to your step to determine what pass-fail is. So in something like test stand, you would have a LabVIEW VI that would produce some measurement value that would get returned out, and then as part of your test stand sequence, you would specify how to check that for pass or fail. Whereas with this, that pass-fail logic is embedded in the steps themselves. So not as separated as something like test stand is. Again, this is not meant to be a test stand replacement if those are the kinds of features that are needed for your application. This is meant for a little bit more limited use case. Let's see. We're gonna need some. Yeah, so we want some protected dynamic dispatch. So we're gonna have a run, and I always use the initiate glyph for this. And we're going to have an initialize. And this is where we pass in the tester. Use just a slightly different icon from my normal Constructor VIs. There, or there, or there, or there. Go with there. These odd pixel width strings are messing with my OCD and feng shui desire for my icons. Let's see, this was, what VI is this at? 24? So this is going to be the init. Okay. So for example, for a child override step where you might be checking that a serial number was written to some embedded microcontroller on some device, your overridden tester class would be, some product tester.lv class as part of your tester library, your higher level library. That would get passed in because your step is written to work on that tester. You would be able to typecast it to some specific product.lv class, using your two more specific type, two more specific class, and then you could get whatever serial interface, JTAG interface, whatever you might be using to I2C, whatever, you could get access to that and do the specific stuff. Let's see here. So community, we're going to have a static dispatch one here that we're also going to pass in the tester. This is going to be run static. So one of the things I like to do when I am doing stuff that is abstract in a base class is sometimes what I will do is I'll do as protected methods, I'll do the dynamic dispatch VIs or groups of dynamic dispatch VIs, and then I'll create in community scope. So in this case, we're always only ever going to want to be able to run a step from our base tester instance, our test class. So to lock down that ability from outside classes, we allow the run method to only be called by our tester class. But then we still want our child classes to be able to override the actual run behavior. Sometimes I do this when I just want to enforce ordering of some initialization stuff. When you're in a VI override, it's up to you. It's up to the developer of that override VI where to put the call parent method node. So I don't like relying on that because sometimes that can go first, sometimes that can go at the end, sometimes things are expecting to be initialized before that gets called, and so if they put it at the beginning, but they needed to call some other VI first, I don't like relying on that. So to reduce the documentation that needs to be provided to the end user, to reduce the chances that the application developer can do things incorrectly, we lock this down so that only our engine can call it, and then this is going to do all of the stuff to make sure these get run in the correct order. So first we'll do our init. I think I do want to change that to up there. And then if our init doesn't have an error, then we call the run. So the init doesn't necessarily have to do anything. That'll allow you to stuff that's not part of pass-fail logic maybe could go in there. Just making sure some instrument is in some known state ready to start sampling. Like maybe you've got an oscilloscope, you've got a scope instrument that you need to get parameters set up, and then once you get into the run VI, you go, okay, start your acquisition. And then it runs, and when it's done, then your run looks at that, analyzes it, does all that fun stuff. Also, our run needs to pass out do we want our run to pass out an overall result, or do we just want to rely on items that get put in? Yeah. Our steps will pass out an overall result for the step. It can pass out no result. If it leaves this unwired, it'll get passed out as no result, and then our tester execution engine won't automatically put an entry in for the step. However, if an error gets passed out of a step, it'll put in an entry for that step as an error. And if you've got really small steps that you have implemented, and you're just making one measurement, testing to make sure it's within some range, you can spit that out. Now, the next question, do we have it pass a variant out as well? I think we will. I don't like having this much stuff that might be potentially unused. Do we always want to force the step to get the result, the current result instance, and pass that, and then add entries to that? I think we do, yeah. We won't worry about a step. This isn't necessarily meant to have teeny tiny individual steps like test stand is, so we won't try and make the application layer or the tester development, we don't want their job to be too simple. But this will more universally cover all of the use cases this is meant for. If you're trying to write the simplest types of steps, you'll have to get the current results item out and manually add some entries to it. So for step, we're going to require that run gets overridden, but we don't necessarily need init to be overridden. And since we've got this static VI that we're calling here, that as we flesh this out, there may be some more stuff that we need to do before, maybe we put automatic entries in for results saying like starting a step, ending a step. Maybe we've got some other messaging layer that gets added into here for some of those callback hooks. And we can handle that all up here. So we're not going to put in this base class, we're not going to put anything in run or init. It is all up to the children to implement that behavior and decide, what has to happen. But it will be possible for them to not have to separate out init and a run. That's just, it's going to be meant as a little bit of potentially a little bit of a separation in how steps are implemented. So if we're doing that, do we want to clean up for a step? We'll just do these two for now. Don't know if there's going to be any public stuff in here. I think that might be it for step. For now. I know I'm going to end up adding more to this later. One of these days I'm going to knock this USB cord loose from a microphone. Okay, tester. This is going to have a bunch of stuff. It's definitely going to have a reference. That reminds me, we need to add some more stuff to our sequence. Like a sequence name. A numme. Get numme. So the execution reference is going to keep track of our current sequence. It's going to keep track of our steps, our current step index. So you're going to be in I32. And it's going to have our current results. So one of the things we want to do to make sure if somebody forgets to clear the results or some other silliness like that, we don't want to leave any partially filled out results in place. So every time we start a sequence execution, we're going to create a new results instance. So we're always guaranteed to have a new list of results. There won't ever accidentally be any existing data stored in there. So this will be the one reference we use for keeping track of whatever is currently executing. I this almost makes me want to break an execution context into its own class. Because that would make doing some of the asynchronous running of the VIs, it would just encapsulate that a little bit better. We'll leave this as is. So let's see, tester. So this is going to be our execution ref. We're going to have a configuration ref. And for this, we're going to want a custom type definition. Failure action. So by default, if something gets a failure, it'll continue running through the sequence. But what you can do is if at the end of a step, it sees that a failure entry has been put in, it can stop running the rest of the sequence, at which point it would run the fail handler, so you still have a chance of running some code to make sure instruments are reset, everything's reset back to default starting known good state. Do I want to put an abort? Yeah, no. We'll just do continue or stop. If this is all it is, I can just make this a Boolean and we don't need this type definition. Don't save. Now, so by default, we'll continue on failure, so it'll keep running the rest of the steps. But we will set this up so that it defaults to, it will stop on error. I think that's going to be it for the config for now. This will be our constructor method. I think we do want a data type for the execution state. We'll put that in as part of our execution. Now, eventually we're going to have a bunch more events, maybe some notifiers, things like that in here. So our configuration ref, we're just going to need to get rid of that, and then we're done. However, our execution ref may contain a current result set. And we're going to want to make sure we clean that up as well, since that is a reference type. Now, we're not actually going to care if that is currently a valid result set. So let's say they open the application and close it down without ever actually running through a sequence. So a result never got instantiated. This will just, we'll let this fail. This will generate an error. We don't care. Now, for our tester, we want to set those as must invoke the call parent method node. Do we want to force descendants to override? I don't think so. I think you'd be hard pressed to create a by value child tester class, but if you do, all the power to you. We won't enforce you to do by reference. By reference just makes some stuff easier, in my opinion. New. So let's do sequence. So we're going to do a VI, and this is going to be to start a sequence. Do we want this to be blocking? Do we want this VI to not return until the sequence is done? No, this will return right away, but it will right away give you the results instance that you can use to track updates. So we're going to implement a handful of abstract dynamic dispatch VIs. These will be some of the initial hooks that are available for starting, for doing functionality like when a sequence is getting started, when a sequence is ending, maybe we can do some stuff that gets run. Additionally, we can have some hooks that get run before and after every step. So some of the what are those called in test stand? I don't think test stand calls them overrides, callbacks. So some of the similar to what exists as callbacks in test stand models. So this was going to be our sequence start. Do I want to call it callback just so people familiar with test stand? No, because we're not using a callback mechanism. Star sequence start. Do you want to call it callback event action? So any of these that are meant to be overridable as different lifetime hooks for a sequence we'll call them actions. Just for a little bit of naming convention and familiarity across the framework. These don't have to be overridden. And the base class is not going to do anything in these. These are just available for specific tester or children type to do things. So like when a sequence starts, maybe you're going to open up some serial communication ports to devices, your DUT, whatever you might want to do. Just get the system ready to run the step. Alternatively, you could do that, with a step that's meant as an initialization step. So again, our steps are just an array of steps. You can use that however you want. We're not going to have the notion of like a setup section of a sequence and then the test section and then the cleanup section. It's a list of steps. If you implement an initialization step, it's an initialization step. And if you don't generate any results in a step, it doesn't have, steps don't necessarily have to have testing logic. Every step is not going to have to generate results. I think for these, let's pass in the step and the sequence. This could allow somebody to do some maybe bad stuff, but oh well. You know, something like this could potentially be used where you don't want these things to go into the results set, but you might need to do things like create a table in a database, initialize a row in a database that you don't necessarily want to be part of a step, but since these are going to get run for, since that other action would get called for any step, that really wouldn't be the best usage for that. That's just an example of the kinds of things that could be done. Do we want you know what? I think we are going to put some behavior in these actions. So the default action will be to put things into some kind of history log that isn't necessarily the result set that says we're starting to run such and such sequence, we're starting to run such and such step, such and such step has been initialized, such and such step has had an error, and then that could be how you change how things like error handlers get invoked, fail handlers get invoked. Yeah, so I think we will use these in the base class, which means we will want to pass in the step and the proceed and the not the proceed, the sequence, things like that. And then if you don't want those entries showing up somewhere, you can just provide your own override that does nothing, or you can take that and push that into a database or anything you want to do. This is a step. So the default, so what's going to be in this parent class here, this base class, is going to be the logic of looking at if an error gets passed into this. So we'll call this VI immediately after completing a step. If that step returned out an error, that error would get passed into this. Additionally, so if it doesn't get an error passed in, it could check to see if that step added any fails to the results. We would have a different mechanism for if it aborts, because if we abort, we're not going to be in this normal execution sequence anymore. So let's have a step abort action. And by default, all this is going to do is get the current sequence and call its abort handler. our default sequence end action is going to finalize the results. So at that point, if it doesn't have any fails in it, it will set its overall status as passed, which reminds me, let's have a finalize or a complete. And we'll add in a little flag here. Well, no, we don't need a separate flag because this is going to stay as no, you know what? We do need a separate flag. And we'll just do a little sanity check so that people can't add. Do we? No, because we potentially might want the tester to add in entries, so we're not gonna track completed. We're doing enough by our base tester class is always going to be creating a new results instance, so we can use that behavior to make sure things aren't getting changed or modified or held over. But we do want a finalize. Must use the one that has an even number of pixel widths. So let's have this return out the overall result, I think. So we're going to look at the overall result. If it is still no result, we change it to pass. In any other case, we leave it as is. Do we want to generate an error if they call finalize and it's already pass? So if like call finalize twice. No, I don't think so. We'll leave that as is. Now, do I want to just implement this as the resulting results, the result? Do I want to implement that as a 2D array that we can just index into based on the current result and the new result? No. Because in any of the ones that might change it, it doesn't care what... Well, no, it does, because if we're putting a fail in and there was already an error put in, it's going to stay as error. So we do need to prioritize a little bit. And we're going to skip this first row and this first column, so these can just be our headers. No, you know what? No, we won't, because I can just put labels outside of it. Freaking upstairs neighbors stomping around like crazy again. Okay, so if it's no result and we pass in no result, it stays no result. So this is existing. This is new. No, this is going to be... I'm going to swap those. Because what we can do is we can do the 2D index array. And then the existing one will be the row, the new one will be the column. And then we get what the new overall result is. So if it is already pass and we get a no result, it goes back to no result until it gets finalized again. That should kind of be an error case, but if we pass in a pass, it's going to stay no result. It'll stay pass. Basically, if we pass anything in, we're going to set it to no result. If it's already fail, or if it's already fail, and we pass in no result, pass, or fail, it's going to stay as fail. If we pass in error, it'll become error. If we pass in abort, it'll become abort. If it was already error, it's going to stay error for everything except for abort. And if it was already abort, it's going to stay abort no matter what. Because one of the things is, because we're aborting, something might generate errors. So we don't want to change the fact that we triggered an abort. We don't want to change the recognition that we did an abort. Entries. And we'll be good LabVIEW developers. We'll get rid of our coercion dots. Sometimes you can't, but I like to get rid of the coercion dots when we can. And there we go. Okay, so we append a new entry, and eventually we'll probably have some kind of event mechanism so that the UI can hook itself in and receive updates that way. So this is going to be our special VI that gets launched via VI server. We'll be able to abort this VI. If we need to do an abort, so step async. And that'll be our way we can call abort without bringing down the whole application. And that is static, right? Yep. So the run step async, pretty much all this is going to do is first, we're going to do our start step, or our step start. Then we're going to run the step. And then we're going to do our step end. Alright, when we run a sequence, we're going to first see what we've already got. Any results we already have. I said results. We're going to clean up. The sequence will get overridden. Step will reset to 0, and state will reset to running. And once we're done with that, we're going to run the sequence asynchronously as well. Oh, that's one thing we can check. We can check to see if we're already in progress. It should be idle or completed in order to start running another sequence. So because we are going to run this asynchronously, that will create the potential for some odd side effects. You'll just have to manage that in your application state. where is that dirty wire hanging out? So we'll just do, actually, you know what, we're not going to need to do that ordering enforcement because we got that Boolean passed out. And we'll potentially raise an error if you're trying to run a sequence while a sequence is still in progress. But we'll decide how to handle that one later. And then that's one of the whole reasons that these would need to be implemented in this manner, is because this stuff is going to be happening somewhat asynchronously. So we're going to want another layer for this. This is going to be our... Oh, that's a nice little tree list sequence thing there. This is going to be our sequence loop async. And so our launch is going to do just that. It's just going to launch. Next, we're gonna call and collect. No. Yes. No. So this is going to be where we do our sequence start action. Well, we're going to get our sequence because we made sure it was stored in the reference before. And we're going to want a results instance. No, do we pass? No, we don't pass it out here. Now from our sequence, we need to get our array of steps. And we're going to iterate over it. Easy peasy. So for each one of these steps, we're going to have a launch step async. And we do need to pass in the step. This is going to be call and collect. Oh, that was the right. So we're not going to close it just yet. We're going to want to do, well, we're going to want to store that in our execution. Reference. So, hey, I totally wired you to that terminal. So we can call abort on that from somewhere else if we need to. And then we're gonna collect this duder. Now, in the run step async, that's where I put the start action, end action. Yep. Now, if this returns an error, I'm not sure exactly what error it's going to return, but we would check this error right here to see if the VI was aborted. Which means I want to get rid of these guys in here. Do we want to pass the step through? I think we might want to. So, if it was no error, we're going to run the default step end action. But if an error gets passed out of that asynchronous node, we run the abort handler action. Now, this will suffice for some initial testing. There's going to be some more synchronization and state tracking we're going to want to do around this. Because basically all we're really gonna rely on is this generating the error. You know what? Yes, let's do that. One of the easy ways we can do that is we'll do this. Okay, so we're going to get the steps, and for each step we're going to do the launch step asynchronous. Well, shoot, do I want to do... Do I want to move these back out one more level still? We'll leave it like this for now. We are also going to want our results so we can get the overall result. Also for our tester, we're going to want a property that says our step index. So here's our getter. We're going to do a setter that's private. So we're going to have a protected property terminate. And this will let our step end action specify whether or not to stop after the current step processing has finished. Terminate. Or do we want to just pass that directly out of our step end handler? I think I like this better. Okay, so we've got terminate. The only other thing we're going to want to do is get the abort. This is going to be another private. It's going to be a fully private. We're going to get rid of this for now. Access scope. Private. Static. So if step end says to terminate, or we've triggered an abort. We'll stop that for loop from running. And if we make it all the way through without terminating or aborting, what did I need the results in here for? I don't think anything. We will go ahead and do the sequence end action. Well, we're going to do the sequence end action anyway. We will pass in whether or not it completed. So we don't, this isn't whether it passed or failed, this is just, did it make it all the way through all of the steps? Which means we put a not, a not out here. Really? Really? Anytime I put anything else in, it messes up the text. I wanted to color these backgrounds so that they stand out as lifetime hooks. Better. Get some Blue Man Group stuck in my head. Not that I haven't watched that DVD in years, probably. Let's see. So we want the sequence, and we want the step index. From the sequence, we're going to get its steps. And we'll index one of those steps out. And so now for something like the UI can get the current step. And retrieve its name or something else it might want to display. Do I want to add a VI to get a step by index? This could potentially reduce memory copies and allocations. Since we won't be passing the entire step array out, and because that's like outside of the VI that actually does that, the LabVIEW compiler might not recognize that we don't end up needing the whole array. And because we're doing things like passing out of references, so it's probably going to, well, I don't know, I can't, oh, that's right. This isn't a reference type. Oh well, this will still be just a smidge cleaner than what I currently have implemented in get current step. Okay, so in start, there are some additional flags we need to reset now. Well, one, we don't need that terminate. We do need to make sure abort is cleared. Our default sequence start is not going to have to do anything. Our sequence end is going to take our results object and finalize it. If it completed. If we didn't complete, we actually don't have to do anything at all. Well, other callback or event mechanisms we might have, we will fire those off. But we don't have any of those yet, so right now we don't do anything unless it's completed. Alright, it's almost 10 o'clock. We've just got a couple more minutes left for this evening. We will pick this back up tomorrow. Where's my step? Now, the way I'm doing that, we could potentially have some issues. If there's an abort out of here, I think we want to go back to the way we had this, because it'll just encapsulate this a bit nicer. And it won't allow, hey, it won't allow anybody that might be overriding these dynamic dispatch VIs from interfering with abort behavior. So we immediately call the tester abort action. We don't need this OR because this is going to get passed out here. What are you chewing on? Are you chewing on a pebble that came in from the patio? What are you chewing on? Don't be chewing on those stones. It's bad for your teeth. Do I want to move this inside now? I think I do. Yeah, I dig that. So end action will only get called if we cleanly end a step. However, if we aborted, the end action will not get called. So this would be one way you could provide some kind of tester override reset mechanism, or making sure just motor power is cut, any other kind of interlock or e-stop condition you have to do. In our default step abort action, we're going to get our result instance. You know what, there's going to be a property node for that. And just to reiterate that this is going to be changing from iteration or execution to execution, we'll always make sure it's named current. So current step, current sequence. From the step, we're going to want to get the step name. And on the results, we're going to add a string entry. So our default step end action is going to first check to see if there was an error. This is going to be one of the very few times I ever wrap an entire VI in an error case. So if it's no error, for now we do nothing. If there is an error, no, what we need to do is we need to see if... I need to sneeze. Whew. We need to see if we got a failing result at this point. You know what, I think we'll just do a static private VI. Check, fail, terminate. Okay, so we're going to do two things. We're going to get stop on fail. From the results, we'll get our current overall result. So if we're configured to stop on fail and we're failed, we stop. Okay, so that one was easy.